Hi, this is Amy Lewis. This is Engineers Unplugged. Hi, and welcome back to another amazing episode of Engineers Unplugged. I'm here with Rick and Matt, and we're going to be, the IOPS don't lie. We got to find out what this is all about, audience.
Take it away, Rick.
Hey, Matt, and hey, viewers. This is going to be a really interesting topic. The IOPS don't lie. This is something that I've kind of talked about when people talk about their modern data center, and one of the biggest problems that is a disconnect between their expectation and the reality of what their storage systems can and, most importantly, cannot do. So, Matthew, tell me the start of the problem.
All right, well, let's start with a basic set of a storage system. So we have some sort of central storage architecture. We have a set of disks. Now, how are disks presented in a meaningful way so that they can actually be used by servers? Let's wrap them up in some sort of thing. I'm usually calling them a RAID group. It's a single set of spindles, and those spindles are used in a way where you can start provisioning logical sources on top of them. On top of that, we have some sort of set of LUNs or aggregates, depending on what the different protocol and product is behind the scenes, and these LUNs are then shared out and used as a resource on the server side. So we can have multiple of these, let's say 2 different ones that are presented, and this could be a SQL database, this could be an Oracle database, it could be a file share, it could be a backup target, it's anything. So here's the situation that we get ourselves into, where multiple sources of I/O are sharing the same physical media, and they're ultimately going to be contending for that. So where does it go from there, and how do the IOPS not lie in your situation, Rick?
Well, what I keep finding is there's a number of things happening in the data center, and it always comes down to the storage. And then how I usually deal with things is how it's moved over the network. But the source is the storage. So what you can have happen is a burst of activity, whatever that might be. Maybe the applications get hot, right? You know, a database gets active, or something like a backup happens. You know, when you talk about a very specific thing like read I/O, backups are very read intensive. I mean, I kind of re-educate people on that, and I have to tell people that the IOPS don't lie because the underlying storage might not have the IOPS to move X amount of data to the expectation of what they have.
Right.
So Matthew, we were talking about, you know, a burst maybe of something like an application or any type of read or write type of activity, file server and SQL server. SQL is always my big problem.
Yeah.
So what kind of things can people do?
Well, let's first think through the math, because we want to talk about
Right.
I/O, and let's get nerdy on the specifics. So I'm talking tier 1 applications. So these spinning media, they're going to be 10 to 15K SATA drives. So at a 15K SATA drive, we're talking about 150 I/O per second. And that's at a 4 KB granularity. That's a basic number that all vendors can agree on for the most part. So that's great. So that means as a total, we can hit about 600 I/O per second at this disk set, and that's including whatever RAID protection is happening on top of it. So that's not front-end I/O from the SQL database hitting this and the file share hitting this. That is an aggregate of all of the I/O, including the RAID overhead that will come and hit this disk. And often, we're calculating front-end and what that will look like from the server side, when it actually adds up to much more on the back end. But that gets even more complicated in your backup scenario, because what are these drives over here, right?
That's right. Chances are what people usually invest in with backup storage is not the same caliber of production storage. So let's take my example here. I've got three drives, and I'm going to do some backup napkin math, and we'll say that they are the best price drives you could buy, right? 4 terabytes and maybe 7,200 RPM drives, and I'm going to put, you know, an IOP number of about 50 or 60, somewhere in that range, depending on what goes on. And if you're talking backups, you know we always fancy things like deduplication, right? And there's this phenomena, which isn't exactly a good thing, called the rehydration tax, which can actually double, triple, or quadruple, or even more the read overhead when it comes to pulling things out of cheap and deep storage over here. So if I need to, you know, barge into your neighborhood, Matthew, and move data in the scope of a backup,
Sure.
you know, I might be able to read here, but am I going to be able to write here? Is that
exactly?
I don't know.
Let's talk like, these are 150 I/O per second drives at 15K. They're usually going to come in at about what? Let's say half a terabyte each at 512 gigabyte. So let's say this is a terabyte file share that you are going to back up in yours. You have a terabyte's worth of data now going from a set of spindles, and all of those are being reads on this side, and they're going to hit these spindles as writes. So that means you're going to have, depending on the network connection in between, a burst of writes on your end, and on our side, reads. So talking about it from my end first, this file share is getting backed up. That's going to be your problem. My problem is this file share being backed up is a bunch of reads from the spindles that will affect my SQL database. So now my SQL database is fighting with this file share for the number of I/O per second that it can retrieve from this spinning media. It's a zero-sum system at the end of the day, and that's an important thing to remember. So you are now stuck with a contention where if the amount of I/O produced here, let's say we've added up to, we've got 600 I/O per second, and then the file share, let's say it's hitting at about 200 I/O per second. We only have about twice that for the SQL, so if we start getting above this number in front-end I/O, we're going to start seeing latency increase exponentially on the front end. So what does that look like on your side? Your writes aren't able to be absorbed by the drives, and this is going to cause some sort of backup to the backup solution.
Yeah, so the good news is that I have plenty of room. Okay, this capacity isn't a problem, it's the performance. So the solution, in my opinion today, is to introduce some form of a new strategy for modern storage systems, and that would include some form of non-rotational storage that you can use, and I'll start with the backup, and Matt will talk about on the primary side. To help these arrows, and whether it be a burst of applications or a backup, you can use non-rotational storage to help. So if I have my big expanse, large capacity here, if I took a smaller amount of capacity, and I'll just say 1 terabyte or such, I could put some sort of non-rotational storage here that is faster, that will help this arrow move very quickly. But Matthew, can I do the same type of thing on the primary side? Because I like my fast storage here, and then after the busyness is done, I'll move it to the cheap and deep. What can I do on primary?
You can do the exact same thing on your primary storage, Rick. So you either have the options that storage systems are very mature these days. They have a lot of tiering applications available to them. But there's also a movement to leave the storage as it is. It's a hard investment to crack and often can be expensive or disruptive at times. So a lot of people are going up to the server tier and looking at what they can do there. And there are tools of aggregating either PCI-based flash or even in-memory alone with a deduplicated cache. So look at your server tier as an option of offloading from storage that could possibly be an easier investment as well. So either way, whether you're doing it on the backup side or on the primary side, you have to let the IOPS tell the truth, and they're going to, whether you like it or not, and result in latency. So let's keep those in mind.
Yeah, one more thing. This little trick of non-rotational storage here, it helps you in that your restores are really quick. That's when you need it, folks. It's worth the investment.
Okay, now we know that the IOPS don't lie. You know what else doesn't lie?
Oh no, the unicorn.
The unicorns don't lie.
I wasn't prepared for this.
Go, unicorn time. Start drawing those unicorns. Oh,
okay.
Don't waste time.
No, Rickatron is not impressed with my own unicorn. It looks like a sick pelican with a impaling lump.
We have the unicorn from more of the Mesozoic period.
Yeah, fossilized version.
And mine's like an 8-bit unicorn. It's very clumpy.
So there you go. The IOPS don't lie, and
the unicorns don't show up.
The unicorns may actually. So thank you so much, Rick. Thank you, Matt. We'll see you next time on Engineers Unplugged.